Smoke me a kipper, I'll be back for breakfast. Hey everyone, I made these video walkie-talkies and I've got one handset and you can see the other handset in the video. So, I'll bring the other handset in and I'll explain to you how it works. So these are the handsets here, and I'll just give you a quick explanation of how everything's set up. So I've got the camera doing all the transmission, so the camera's connected to the microphone, and the screen, the TFT, doing all the receiving, and these TFTs have a built-in esp32, so there's two esp32s in each handset, so the screen is connected to the speaker, and that's all the receiving, and then this is all the transmission. Now these cameras have a built-in microphone, but this side I'm using this microphone, which is the MP441. This side, this isn't in use, although I put it on the circuit board just in case I wanted to use it. And then I've got the 18650 battery connected to power everything. And then the button is just for speaking. So if I press the button, you can see my face come up. Hello? Hello? So that's with the built-in microphone. And this is with the external MP441. Hello, external microphone. So now the audio is being transmitted over esp-now and the video is being transmitted over Wi-Fi. Each camera is set up as a separate Wi-Fi access point, so it's a soft access point, so it's not dependent on any local Wi-Fi, which makes it a little bit more portable and also a little bit more private. But the range is probably around about 30 meters. So in the rest of the video I'll take you through the project and how I made it and the processes and stuff and explain the software and the hardware. Okay, I'll see you in the next scene. Hey everyone, so before I start a project I usually gather everything I need in a Tupperware container. So let's see what's in this Tupperware container for the video walkie-talkie esp32 cam project. Okay, so first thing I'm going to need, of course, is an esp32 camera. And I'm using this one from xiao, which is esp32 S3. So I'm going to need two of those, one for each handset. So I'll just move this out of the way. Okay, so now I was going to use the esp32 AI Thinker, which is like my favorite go-to esp32 board, but this is an S2 and the S2 doesn't handle video and I2S at the same time, so I can't do sound and video simultaneously. So because I wanted to do them both simultaneously, audio and visual, I had to go with esp32 S3. So I went with this xiao. Okay, so of course, because I've got a video walkie-talkie, I'm going to need a screen. So I'm going to use a cheap yellow display on one handset, and I've got this display, which is a red display that Elecro sent me, and they sent me that to review. So I'm going to have a look at the comparison of these two as well. Or I could just use two cheap yellow displays or two of these, but this has also an ESP32 in it as well. And then I'm going to need some speakers as well for the sound. So I've got these two speakers that I think these are 4 ohm. I got these off just off Amazon. Don't get like super cheap ones off AliExpress because the sound's not very good. These aren't like expensive, but they're not like the super cheap ones. And I guess an amplifier, so for the sound. And I know these have built-in amplifiers in them, but I've heard that the sound quality is really bad. So I'm just going to test with the built-in amplifier, which is probably preferable. And this Max 98357A amplifier. So, and then I'm going to need, I guess, a couple of push buttons and a microphone. So I'm going to need probably, this is an MP441 microphone in here, and I know that the xiao, this esp32 cam has a built-in microphone, but I'm not sure what the quality is on that. So I'm going to test that out and see if it's better to use that or one of these microphones. So the way I'm going to have it set up is I'm going to have the microphone and the camera on this one. So this is going to be detecting the input, and then I'm going to have the speaker, I guess, and the visual coming out of the cheap yellow display or this screen here. So this is going to be I guess, streaming the output. So I'm going to have one handset over here, and I'm going to have this one here, I guess, streaming video and audio to this one, and then this one here transmitting to this one. So I'm going to have one as a transmitter and one as a receiver, but I'm going to have two ESP32s on each handset. So now I guess the next step is, I guess, to test out the amplifiers and the microphones and then put everything together. Hey everyone, so I'm going to use this cheap yellow display for one handset for the video walkie-talkie, and this red one that Elecro sent me for the other handset. And at the moment I'm just streaming onto them from my webcam, and I'll put the code for that up on my GitHub. So we can look at the picture and we can see on the cheap yellow display it looks a little bit washed out, whereas on the red one it's a bit sharper. So I've got the webcam pointed at these are some shrink wraps for some wires, and they're fairly colorful, and I just wanted to display something colorful on them so we could get an idea of how sharp the color was. And I'll just hold them a bit closer to the camera so you can see. So that's the red one, and now this is the yellow one, and the yellow, you see that one's a little bit more washed out. I'll just hold them next to each other. Yeah, so the Electro one is a little bit sharper, but I guess the other difference is, which I'll discuss next, is the pin outs for them. So this one, the way that the pins are arranged on the back, they're all labeled. So I'll just move the camera a bit so we can get a better view. All right, so these ones, they break the pins out with these JST connectors, and for the yellow display you need a 1.25mm pitch JST connector, which is like this one here, there. And then for the red ones, the Elecro one takes a 2mm pitch JST connector, and they come with what they call these crow tail connectors, but they only come with one. So each of these, they only come with one 4-pin connector. So you're going to have to get extra JST connectors, and you just have to remember what size pitch you need. So it's 2mm for the red one and a 1.25 for the yellow one. And the other thing I wanted to discuss, I guess, is the amount of usable pins. So this one here, the red one, which I thought was quite good, breaks out 5 fully usable pins, 5 fully functional pins, I/O pins, whereas the cheap yellow display only breaks out 2 fully functional I/O pins, pin 22 and 27, and then pin 21 is connected to the backlight, and pin 35 is an input pin only. But we'll discuss a little bit more about that later. So in the next scene, I'll hopefully try to get some sound working with these boards. Hey everyone, so I've connected the speakers up to the cheap yellow displays, and I'm trying out 2 methods. One is to use the inbuilt DAC on the cheap yellow display, and that's much more convenient because I can just connect the speakers straight to the display. And the other is to use a Max 983578 amplifier, and that's a little bit more difficult because it requires 3 pins. But I've heard that the quality on the inbuilt DAC is really bad, so I'm just going to test that out. And to test that out, I flashed like a radio sketch that was on Brian Lock's GitHub on the cheap yellow display, and it was written by Johnny Bergdahl. And I've just got it pointed to a classical music station at the moment, so I'll plug that in and we'll see how that sounds. First we'll do the one with the built-in DAC, and we'll see if that's any good. So you can see who it's playing. It's George Philip Telemann, and The sound isn't very good. Alright, so now let's try the other one and see with the amplifier and see if the sound is any better. Okay, so the sound is much better. It looks like there's a few dropped frames, but we are getting much better sound. Okay, so it looks like I'm going to use the amplifier for the project. Just to be fair to the Electro display, I'm going to show you what the speaker sounds like when it's connected to the built-in speaker output, and I've got the radio sketch loaded on there at the moment, so I'll plug that in and we'll get that started. So it's playing Brahms at the moment, and that does sound a fair bit better than the cheap yellow display, although it still don't feel like it's good enough for a walkie-talkie. Right, so in the next scene, hopefully I'll have the video and image working from the camera. Hey everyone, so I've got everything working now, and I've got this camera here hooked up to the red display, the Electro display, and this camera here is hooked up to the cheap yellow display. This camera here is connected to a MEMS INMP441 microphone, and I'm just using the built-in microphone for this one, which is a PDM microphone, and I wanted to test which one was better because I really didn't know if I could trust the built-in microphone given how bad the built-in amplifier was on the cheap yellow display. So I'm going to test those now. So first I'll test the PDM microphone, and I'll hold the speaker a bit closer here to the camera just because it doesn't seem to be coming through very well on the camera mic, even though I can hear it. And I'll pick this up and I'll talk. Hello.
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 So that sounds pretty good. And then I'll do it with this one now. So I'll pick this up. And I'll talk. I'll hold this closer. Hello.
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 Okay, so this one here is actually a bit louder than this one, but I think I'm going to use the built-in microphone just because it's just less wiring. But I have printed up these boards here. These boards I printed up from PCBWay, and they were like $5 for 5. And this was actually a lot easier than doing it on the breadboard. Originally, I did do it on the breadboard. So originally I had it all wired up on this breadboard, but every time I tried to film it, I would knock a wire out or something, and then like it just spent too long troubleshooting. And the connections have to be quite good because it's like relatively high frequency. I'm doing like 16 kilohertz. If you're doing like 16 kilohertz at 32 bits per sample, you know, that's like, you know, 500 kilohertz or more, you know, that you need to sample at. So, you know, it's pretty important to have, I guess, good connections, and that's something you get with these boards. So the next thing I'm going to do, I'm going to print out like a box for them on the 3D printer. So I've got a box for the walkie-talkies, and I'll take you through the code as well, and I'll just show you like the more tricky parts of the code, and then I'll put all that code up on GitHub so you guys can have a look at it if you want to. Okay, thank you. Hey everyone, so I'm just going to take you through the code that I used for the video walkie-talkie, and I started off with Chris Greening's code from Atomic 14 for his walkie-talkie, and he uses one project for both transmission and receiving, but I've split it into two and I've added video to it. So I use one project for transmission, which is video and audio transmission, and one code for receiving the video and the audio. So one project for each. So I'll show you the first one here, which is the one that's connected to the display. So this is called display side. And I'll show you, you can go through the code, but I'll just show you a little bit about the configuration. because it's going to be a little bit different depending upon if you're using the red aliexpress display or the cheap yellow display. So now, so the configuration here at the moment, I've got it set up for the cheap yellow display, and I've defined this CYD display thing here, which will assign the pins that I want to use. So for the cheap yellow display for the amplifier, I'm using pin 22 for the serial clock, pin 21 for the word select, and then pin 27 for the data. Now, if you look at the wiki on this, it says that pin 21 isn't really usable because it's connected to the backlight on the display, but there is a way you can use it. And so basically what you have to do is in your configuration file, you have to set the backlight to -1. So basically, you're basically saying that the backlight's not connected. In the normal code, you'd set it to 21 basically, just because that's where it's hardwired to. So you want pin 21 to be high for the display to work. But if we're using pin 21 for the word select, let's just go here. We see the word select is like high half the time, so it's like a PWM signal. So basically it's on. So because it's hardwired to the backlight, just by the fact that it's on, the display is going to work. So that's how we use that. And then I guess if we're using the red display, which has, I said before it had 5 fully usable pins, but it actually has 6 fully usable pins. If we're using the red display with 6 fully usable pins, we use, for the data pin, we use the 22 and 21, and then for the data pin, we use pin 25, and then pin 27 on this is connected to the backlight. But then, of course, we have another 3 usable pins which aren't being used. Okay, so that's the first bit of configuration, and I guess the second bit of configuration is in here. So if we're using the cheap yellow display, we connect to this SSID, which I guess because we've got the camera acting as a soft access point, so depending upon which handset we're on, we're going to want to connect to the SSID of the other handset. So I've just named the SSID esp32 cam AP and esp32 cam AP _red, and to be honest, ChatGPT came up with this name for me, and then the password is just 1 2 3 4 5 6 7 8 9. You can just use any password or SSID you want. So there's that, and then because we're connecting to the camera that's acting as a soft access point, this URL is always going to be constant. It's not going to change. It's because it's the one that has the access point is always going to be .4.1. So that's pretty good. So you can read that code, and then I guess in the TFT stuff as well, if we're using a different CYD display, for this one we need to invert the display, otherwise the colors are going to be a little bit different. We're going to have, like, instead of green, we're going to have red and stuff like that. So also I guess in the application, because this is on the display which is receiving the audio, I've commented out all the transmission or all the audio transmission stuff from Chris's original project, and I've just left in the audio receive stuff. So I mean, you can go through the code. It's actually, Chris's code is actually pretty good. So he uses, basically, to receive, he uses the circular buffer, which means that the sound basically comes through constantly. So it gets to the end, and then it goes back to the beginning, and then so it keeps kind of going round and round, which means that you get a continuous sound. You don't get any interruptions, which is pretty good. All right. So the next thing I'll show you now is the code on the camera side. So let's have a look at that. And so the configuration for the camera side, as well as you have to configure it for whichever handset you're on. You also have to configure it if you're using the MEMS INMP441 microphone, or if you're using the built-in PDM microphone. So for the built-in PDM microphone, you have the WS pin and the data pin, and the WS pin is 42. This is hardwired, and the data pin is 41. This is hardwired with the xiao, with the seed xiao, and then the other pins are not actually connected. And then for the INMP microphone, you need to define 3 pins, and I'm just using pin 2 for the data, pin 4 for WS, and pin 3 for the clock. And on the xiao Sense, the esp32S3, you can pretty much use, the pins seem to be pretty versatile, so you can pretty much use any of the pins you like. Also, what else can I show you in here? Okay, yeah, so this is, if we're using the, I guess, because we're transmitting the sound, we need to have the MAC address over esp-now. We need to have the MAC address of whatever device we're transmitting to. The receiving device doesn't need the MAC address of the transmitting device. You only need the MAC address of the receiving device, and then you can send it data. So provided it's set up to receive esp-now data, it doesn't care what MAC address has sent that data. So this is the MAC address here, and of the CYD display, and then the red display has this MAC address here. So you have to configure that depending upon which handset you're configured to. And then I guess the other thing is, once you sample, you get your samples right, and it took me a while to work this out. Oh, where is it? It's in here. So basically, what they do in the original code is they shift the sample, like, well, they had it shifted 11 bits to the right. I'm shifting it 12 bits though, but just because I wanted to turn the volume down a little bit. So shifting it by an extra bit is like dividing it in half. And it took me a while to work out why they're doing that. And the reason why they're doing that is because when they transmit it, they're sampling 32 bits, but when they transmit it, just to make the transmission faster, they only transmit 8 bits at a time. So in order to get the most important 8 bits to the bits that they transmit, they have to shift it by 12. And this is for the microphone, which is sampled at 32 bits per second. So let's have a look. So these bits here are the only bits that are being transmitted out of the 32 bits. They're the bits they extract to transmit. But the bits marked M are the most important bits. So they've got M for most. So they've got the most information in it. So when we shift it over, well, if we shift this over by 11, I'm shifting it by 12 just to turn it down. But if we shift it over by 11, what we do is we basically, we move these over 11 places. So we're moving all these M bits to here. And then we're only transmitting, so this here is shift by 11. I'll just put that comment in. So then we just transmit this bit here, which means that we're getting the most information. And now, because I'm doing a 16-bit sample for the PDM microphone, I have to shift 3 bits, but in the opposite direction, because I've got 16 bits. So I've only got this here, I've only got this amount of bits, and then my information is basically here, which means I have to shift 3 bits over, and I transmit most of my information. I could put that up to 4 to turn the volume up again, but yeah, I just found that the volume worked well with these settings. So that's the only thing that I guess took me a fair while to work out. Hey everyone, so I've assembled the video walkie-talkies into these boxes that I 3D printed, and I mounted them on these nylon standoffs, and I put things up a little bit high just so I can get these 18650 batteries in underneath. So now I'm going to switch them on, and let's hopefully they work. Alright, so they're both working now, and let's test out the speaker bit. Hello? Okay. Hello? Hello? Okay, so the speaker's working, but the problem is because they're close together, there's a bit of feedback. So I'm just going to take this one here out of the room and I'm going to talk into it, and I'm going to leave this one here in front of the camera, and hopefully that'll work. Smoke me a kipper, I'll be back for breakfast. Thank you for watching, everyone, and I'll see you in the next video.